Hello everyone, welcome to another module in this online course Strategy and Introduction to Game Theory. So we are looking at auctions and we have been modeling auctions as Bayesian games, and we have so far looked at a first prize auction, a Bayesian first prize auction where the valuations are distributed uniformly. We had derived the Nash equilibrium of this first prize auction, and we also derived the expected revenue of this first prize auction. What we are going to look at today is another auction format, an interesting auction format termed as the second prize auction. So we are going to look at Bayesian, a second prize auction. So what we are going to look at is a second prize auction, and this is a key word, second. Right. So this is a second prize auction. So we have looked so far at a first prize auction. What we are going to look at today is a second prize auction. Now what is a second prize auction? Again, let us consider an auction with two players, that is, let us say we have two players or two bidders. Let us consider a two player auction with the players denoted by P1, P2. These are the players, and let their respective bids be denoted by B1, B2. Let B1, B2 denote their respective bids. That is, we have two players P1, P2. P1 is bidding B1 and P2 is bidding B2, right? And once again, if the player, the bid B1 is higher than or equal to B2, then player 1 wins the auction. If the bid B2 is greater than or equal to B1, then the player 2 wins the auction, right? So the winner, so if again B1 is greater than or equal to B2, then player P1 wins the auction, or let me write it a little bit more clearly. If B1 greater than or equal to B2, then P1 wins the auction. If on the other hand B2 greater than B1, then P2 wins the auction. So this part is similar to the first prize auction, that is, winner with the highest bid wins the auction, right? So winner with the highest However, in the first prize auction, the winner pays equal to his own bid. However, in the second prize auction, the winner pays the second highest bid. So the winner, after winning the auction, pays the second highest bid. This is the second prize auction. So if B1 is greater than or equal to B2, then P1 wins and he pays the second highest bid. Now since there are only two players, we are considering a two player auction, the second highest bid belongs to that of player 2, that is B2. So he pays an amount equal to B2 to get the object, and pays, P1 wins and pays the second highest bid, that is B2, right. So what we are saying is, if B1 is greater than or equal to B2, then P1, that is player 1 who has the highest bid, wins, and he pays the second highest bid, that is B2, to get the object. Similarly, if on the other hand if B2 is greater than B1, then P2 wins the auction and pays the second highest bid, that is B1. and pays equal to the second highest bid, that is B1. So we are saying that this is a second price auction where the bidder or the player with the highest bid wins the auction and he pays an amount equal to the second highest bid to get the object. Therefore, this is a second price auction, right? Also in this auction, similar to the first price auction, each user has or each player has a private valuation. Let us denote the valuations of player 1 and player 2 by V1 and V2 respectively. Each player has a private valuation. Each player has a private valuation. Let us denote these valuations by V1 and V2 respectively of players P1 and P2. So, let the valuations of P1 comma P2 be denoted by V1 comma V2 respectively. So, let these valuations be denoted by V1 and V2. Further, similar to the first price auction, we are going to assume that these valuations are independent and are distributed as uniform random variables in the interval 0 to 1. So, we are going to assume that V1 comma V2 are independent, right, and V1 comma V2 are distributed as uniform random variables in 0 to 1. That is V1 and V2 are independent random variables which are distributed uniformly in the interval 0 to 1. Therefore, the probability density function, you might remember the probability density function of the uniform random variable, that is, if you look at the uniform random variable in the interval 0 to 1, we have the probability density function f of v equals 1 if 0 less than or equal to v less than or equal to 1 and 0 otherwise, right. So, between the limit, so in the interval 0 to 1 the probability density function is 1 and outside the interval 0 to 1 it is 0 everywhere. So, this is the uniform random variable between in the interval 0 to 1. Okay, so, we are saying both the valuations V1 and V2 are independent and they are distributed as uniform random variables in the interval 0 to 1. Now, let us again analyze this game in terms of its Nash equilibrium. We are going to demonstrate that the Nash equilibrium of this game, so the Nash equilibrium of this second price auction is given as P1 equals V1 and B2 equals V2. That is, what we are saying is that each player bidding his true valuation, that is B1 equals V1 and B2 equals V2, is the Nash equilibrium of this Bayesian second price auction. To analyze this, to verify that this is indeed the Nash equilibrium, let us assume that B2 is bidding, that player 2 is bidding his true valuation, that is B2 equals V2, and let us try to derive the best response of player 1. So, let us start with the assumption to demonstrate that this is indeed the Nash equilibrium. Let us start with the assumption that B2 equals B2, that is player 2 is bidding his true valuation B2 equals V2. What is, let us find the best response of player 1. Let us find the best response bid B of player 1. Let us now find the best response bid B of player 1. For this, let us consider two scenarios. Let us assume first that the valuation V1 is greater than or equal to V2. Let us consider the first case, case 1, let V1 be greater than or equal to V2. Alright. Now, if V1 is greater than or equal to V2, that is the valuation of player 1 is greater than or equal to V2, let us try to find the best response bid B of player 1. Now, now remember player 2 is bidding B2 equals V2. Right. Now, therefore, if player 1 bids any B greater than or equal to B2, that is any B greater than or equal to V2, he wins the auction. So, if B greater than or equal to V2, then he wins, player 1 wins the auction, then player 1 wins the auction, and his payoff is remember, once he wins the auction, he is paying the second highest bid, but the second highest bid is V2. So, his payoff is his valuation V1 minus the amount he pays, that is V2. So, he wins the auction and pays the second highest bid, that is B2 equals V2. So, he is paying an amount equal to V2. Therefore, his payoff is basically the valuation minus the amount he is paying. So, net payoff equals valuation V1 minus amount he is paying V2, which is greater than or equal to 0, because V1 is greater than or equal to V2. On the other hand, if he bids B less than or equal to V2, if he bids B less than or equal to B2 equals V2, then he loses the auction. Then player 1, that is player P1, loses and his net payoff is 0, since if he loses the auction, his net payoff is 0. Therefore, we have two cases, right. One, if the bid B is greater than or equal to B2 equals V2, he wins the auction and his payoff is, well, his valuation V1 minus V2, which is greater than or equal to 0. On the other hand, if B is less than V2, that is B is less than B2 equals V2, which is the bid of player 2, then he loses the auction, and if he loses the auction, he does not pay anything, he does not get anything, therefore, his net payoff is 0. And therefore, you can clearly see if he bids any bid B greater than or equal to V2, right, his payoff is V1 minus V2, which is positive. Therefore, any bid B greater than or equal to V2 is a best response. In particular, V1 which is greater than or equal to V2 is a best response bid. So, we see any bid, therefore, we see that any bid B greater than or equal to V2 is a best response. In particular, B is equal to V1 is a best response. So what we have seen is that if the valuation V1 of player 1 is greater than or equal to V2, the valuation of player 2, and player 2 is bidding B2 equals V2, then B equals V1 or B1 equals V1 is a best response bid of player 1. Right. So we have considered the case, successfully analyzed the case when V1 is greater than or equal to V2. Let us now consider the other case where V1 is less than or equal to V2. Let us now consider V1 is less than or equal to V2 and player 2 P2 is bidding B2 equals V2, right. Now if player 1 bids B greater than or equal to V1, if P1 bids any B greater than or equal to B2 equals V2, then he wins the auction. And he pays the second highest bid, which is B2, and therefore net, that is B2 equals V2, therefore net payoff is his valuation V1 minus the amount paid, which is V2, which is less than or equal to 0, right. Because V1 is less than or equal to V2, if he bids any amount B greater than or equal to V2, he wins the auction, right, and he pays the second highest bid. The second highest bid is B2 equals V2, so he pays an amount equal to V2. And what is his net payoff? His net payoff is V1 minus V2, which is less than or equal to 0, because V1 is less than or equal to V2. Right. On the other hand, if he bids any B which is less than B2 equals V2, then he loses the auction, and his payoff and his net payoff is 0. So if B less than B2, that if he bids any bid B which is less than B2 equal to V2, which is the bid of the second player, that is player 2, he loses the auction and his net payoff is 0, right. So if he bids any B that is greater than or equal to B2, then he gets a negative payoff. If he bids any bid B which is less than V2, then he gets a payoff of 0. Obviously bidding any bid B which is less than V2 is a best response. In particular, since V1 is less than or equal to V2, bidding his valuation V1 is a best response. So a bidding any bid B, therefore any bid B which is less than B2 equals V2 is a best response. In particular, B equals V1, that is bidding is true valuation V1 which is less than V2 is a best response. In particular, bidding B equals V1 is a bidding B equals V1 is a best response. So, we have considered two cases. We have considered a case where either V1 is greater than or equal to V2 or V1 is less than V2, and in both the cases we have shown that bidding B equals V1, that is the bidding B equals V1 is the best response for player 1, that is bidding is true valuation B1 equals V1 is the best response for player 1, and therefore, we can conclude that basically that if player P2 is bidding B2 equals V2, then B1 equals V1 is a best response for B1 equals V1 is a best response for player P1. Similarly, we can repeat it from the perspective of player 2, that is if player P1 is similarly, it can be shown, it can be argued that similarly it can be shown that if player P1 is bidding B1 equals V1, then B equals V2 is a best response for player 2, that is P2. Therefore, B1 equals V1 constitutes a best response to B2 equals V2, B2 equals V2, and similarly when B1 is equal to V1, B2 equals V2 is the best response of player 2. Therefore, B1 equals V1 and B2 equals V2 are the best responses of each of the players. Hence, the Nash equilibrium of the second prize auction is B1 equals V1 and B2 equals V2. Hence, the Nash equilibrium, hence and what is important here is to realize that each player is bidding his true valuation, that is player 1 is bidding his true valuation V1 and player 2 is bidding his true valuation V2. Therefore, each player bidding his true valuation is the Nash equilibrium of the second prize auction. Therefore, we have shown that therefore each player bidding his true valuation is the Nash equilibrium for the therefore, each player bidding his true valuation is the Nash equilibrium for this second prize auction. To summarize, B1 equals V1 and B2 equals V2 constitutes the Nash equilibrium for this Bayesian second prize auction. And in the next module, we are going to derive the expected revenue to the auctioneer for this Bayesian second prize auction. Thank you.